you will notice that it basically translates the point data into Rhino. So what you're looking at here is just a whole bunch of points on this particular file. Are you able to view it?
Yes.
Yes.
Okay, great. So if you take a look at the Rhino 3D Print browser, it shows that you have one point cloud data in here. It shows how many points are in this, and it also gives you information about the volume here. You have the length, width, and the height, as you can see it. Now you can still use all of your Rhino tools. If you want to rotate this forward, I can rotate it over so it lays it flat, so 90-degree rotation. So we got this point data. Now what can you do with this point data, right? So you need to be able to like, convert it into a mesh so you can actually machine it, right? So we have a tool called Create Mesh from Point Cloud. So you select this Create Mesh from Point Cloud. It says select the point cloud to create meshes. You just highlight this point data, and then you press enter or right click on that. Now this basically displays the dialog below in here to specify the parameters for mesh creation. What I'm going to do is, since this file is in millimeter units, as you can see right there, I'm just going to use a search radius. I'll put in 10 millimeters and leave everything else as default, and then hit create. You will notice that now it takes each of those point data and converts it into a mesh, like an STL file. And your mesh has been created, and you can see that the mesh object shows up in this data tree. And I'm going to hide the point data so it makes it easier for us to view the mesh. Now when I click on Shade Display, you'll see that it created a mesh from the point data and did a pretty good job. But you do see that there are several holes on this mesh, right?
Yes.
Now, how can we fix those? We can go to the tab called Repair, and before I fix the holes, I want to do a diagnostic run and see how many open holes are there. So what I'm going to look for here is just for open holes. And I'm going to hit Run Check, and you'll see that it identified close to about 16,000 holes. You see each of those, the vertices marked in red, the edges of the triangle marked in red, they're all open holes in the model. Now let's go ahead and fix this here. There's a one-button click command called AutoFix. This is a very powerful command where it can automatically fix holes, fix self-intersections, and close to make it a watertight mesh. So right now it's working on performing the AutoFix operation in here to fix this open mesh to form a closed watertight model. Now once this is fixed, you will see the result of it. Now we currently have over 228,000, so just under 250,000 triangles on this. And there's your mesh. It's fixed.
Very cool.
If I go back in here and perform a diagnostic check again for open edges, you'll see that it says no issues detected. Now this model is currently ready for generating your toolpaths. You can go into RhinoCam and generate toolpaths. Now if you want to make some changes, so let's say for example you wanted to reduce the number of triangles in here, you can actually go into Inspect and Modify. You can say Reduce Mesh. You can select the object, the mesh geometry. You can specify by how much you want to reduce. You can either do a percentage, or you can say by maximum deviation. I can say reduce it down maybe 30%, make it smaller by 30%. And when I hit Reduce, it'll go ahead and reduce this mesh. So instead of being at 228,000 triangles, it's now down to like close to 160,000 triangles on it. And you have unlimited undos and redos. You can just do an undo in Rhino, it'll undo it. Now, once this model is ready here, you can go to the process of machining it here. So if you need to rotate the model to line it up, so I can use the commands in Rhino to line it up right there. And we can go into RhinoCam for machining it. So you just go to RhinoCam and select your mill browser and generate your toolpaths.
Man, you make it look easy, Renee. That's very cool.
Well, it is. As you can see, it's just a few button clicks. You bring in a model, you create your mesh from point clouds, and then you repair it, and then it's ready for machining.
Now we have a working model. To make a toolpath, since we have the 3D geometry already there, we will make sure that our correct post-processor is selected. We're assuming our machine setup is already configured. We can set our stock. We use box stock. I want this set to the origin. I'm purposely leaving it off of the edge of the part. So I'm going to oversize my stock just based on the board that I have available. So My length I'm going to bring up to about 4 inches and oversize the width as well. The board I'm using is 3/4 of an inch thick. You can see that the stock changes accordingly. We can verify from all angles. You can see from the top or from the side view I'm still a little high. I'm going to drop this model down to the plane. Now we have a little more material to remove from the top of the part. All we're going to do is come into 3D Advanced, and we're going to use a parallel finishing toolpath. I'm going to do this in 2 parts. So I'm going to create a tool, and first I'm going to use a roughing tool. So I want an end mill at 1/4 inch, tool number 2 for my current setup, 1/4 inch end mill. My feeds and speed should be loaded from the tool automatically. Clearance plane, since we set up our stock, should come up no problem above our part during those rapid moves. Our cut parameters, now I don't mind this being mixed, raster running a conventional incline cut, alternating, but because of the direction of the part, I'm going to rotate this 90 degrees so that it runs down the length of the part. Percent of the tool diameter, since it's a roughing tool pass, I'm going to have a fairly aggressive step over at about 35%. Entry and exit, I'm going to leave the default parameters for now. We're just going to hit generate. Our tool path, you can see the tool path working there. If we want to simulate, we can come over to the simulate tab and hit play. You can see it's pretty aggressive. We start to see a little bit of the texture, but all we're looking for is the basic shape and to get rid of most of the material here. So I'll come back over to program. I'm satisfied with the way that looks. And I'm going to rename this since they are both parallel finishing passes. I want to make sure I distinguish between the two so that they're in the proper order. I'm going to create another parallel finishing. I'm going to use my ball mill this time. My feed rate's a little high, so I'm going to make sure I load from tool and drop that down. Clearance plane, automatic is still okay. Parameters, this time we're going to leave our stock as 0, no offset. We're going to set our angle of cut to 90 degrees as well. And this time we're going to drop our step over control down to 8% so that we get a fairly smooth finish to minimize our cleanup work after the fact. No need to worry about Z containment, entry, exit, or cut, advanced cut parameters. We're going to leave the default values for all of those. There we go. And if I come back over to simulate, the first tool path is already done. I can select the second tool path for simulation. As you can see, this one's going to take a bit longer. If we let this simulate for a few minutes, we will come back and see a fairly accurate result of what our finished part is going to look like. And there you have it. Once the simulation's done, we can turn off the visibility of our tool paths to get a better look at the part. And you can see within a few quick steps, we went from an imported model to our code ready to post. If we're comfortable with the way the simulation looks, we can come up to Setup, right-click, and click Post. This will generate our G-code. Now we're ready to take it out to the machine and see how it cuts.